Okay, so we're going to start 1.7b, which is solving absolute value inequalities. Before we start, you're going to write down 3 things that you learned, 3 things that we talked about yesterday that have to do with this equation right here, this absolute value equation. Okay, you got 3 things? Somebody want to give me one of them? Come on, be brave. Yes?
There's no distributive property.
There is no distributive property. Very important, okay? You cannot distribute through an absolute value. So you can't just call this 2 times the absolute value of x or 2x or whatever. You cannot distribute throughout an absolute value, okay? Somebody tell me something else.
You need to get split into 2 cases.
You're going to need to make 2 cases, okay? You're going to have 2 cases. One where it takes whatever that answer is on the right-hand side or the left-hand, depending on where it is. And the other one where you took the opposite of that answer. Very good. Somebody tell me another one.
Always check it.
Always check it. Why are you checking it? What happens? Why did I say make sure you check these? What are you really checking for?
To see if it equals out to what it says it equals out to.
Okay, to see if it equals out. What if it's you work the problem all right, but then when you plug it in, it doesn't work? What's that called? Extraneous. Okay, so what you're doing is you're checking for extraneous solutions, which are correct solutions that do not check. Okay, so is every answer that doesn't check necessarily extraneous?
No.
What could it be?
Messed up.
Yeah, messed up, wrong. Okay, it could be wrong. Guess what, people? If it's wrong, it won't check. But that's not extraneous. Okay, an extraneous solution is a correct solution that does not check. Okay, so let me tell you some things that I see, that I think about. The first thing, when I see that absolute value, my brain goes, ooh, how many answers am I going to get? 2. All of the time? No, not all of the time. Sometimes I'll get 2 answers and none of them are checked, or maybe one will only check. Sometimes I won't have any answers. Sometimes I'll have 1 answer. But this absolute value makes my brain think, oh, you better be thinking now, because we could possibly have 2 answers from setting up these 2 cases. Now, let me talk about these 2 cases, because I saw some of your janky work the other day, all right? And some of you think you're smart enough to do this without setting up your 2 cases. People, did I set the example for the 2 cases the other day? Yes. Okay? I tried my best to set a good example for you. Okay? I don't always set a good example, but I try to, especially when I'm in here. Okay? So I set up these 2 cases. If you don't set up your 2 cases, you're losing 10 points right off the bat. I'm just going to go -10 on your paper. So if you work those first 10 problems and you don't have case 1 and case 2, you better go back and fix it. It's due next class period. Okay? And if you didn't do that, you already lost 10 points. Anybody got a question? Okay, so if I was going to solve this equation, tell me what I would do first.
Divide by 2. Oh, sorry. No.
Okay, so if sometimes that confuses you and you're like, I'm not really sure what I'm supposed to do this. Take this whole absolute value and pretend like it's a variable. Okay, so do you agree that the equation would be 2a, or whatever your variable is, plus 6 equals 10? Do y'all agree with that? Mm-hmm. How would you solve this equation? Subtract 6. That's what you would have to do here. So if you don't see it sometimes, just pretend like that whole thing is a variable. variable, all right? And how would I solve that equation? You always add and subtract first, and then you multiply or divide to get rid of things, okay? Because you're undoing it, so you have to kind of undo it backwards. All right, so, let's go down here and let's write how we're going to solve an absolute, because this is what we're doing today, an absolute value inequality, which means that we're going to have greater than or less than signs. Does everybody agree?
Yep.
Okay, so the very first thing you're going to do is exactly what you did up here. You are going to isolate. What does that mean?
Okay, get back to
You got to get it all by itself. Isolate the absolute value. Okay? Isolate the absolute value. Get it all by itself. Y'all listen to me. You cannot tell what it is until you get it by itself. Okay? You cannot tell what it is until you get it by itself. The second thing you're going to do, notice I'm leaving some room right here because I'm going to write above what I'm fixing to write now. You're going to decide, is this an and statement or is this an or statement? Okay? Is this an and statement or an or statement? Now, you should know this because we learned this the other day. We learned this for your test on 1.6, so you should already know it. Who is going to be an or statement? What kind of sign?
the U.
What kind of sign?
Greater than or equal to.
Or just a greater than, right? But yes, you're right. What kind of inequality? A greater than. This is greater than is or, all right? He's going to look like this. He could be greater than, or he could be greater than or equal to, whichever one you wanted to. Which one's going to be an and statement? Less than is going to be an and statement. Okay, good job. Less than. Kind of rhymes with and. All right, and he's going to look like this, or he could be the or equal to. All right, anybody got a question? Okay, so let's talk more about them. And statements are always written how? Does anybody remember what we wrote down? Yes, as one. So we write them together. Very good. Okay? All right? And statements are always written together. And you remember what we talked about? We talked about those signs doing the same thing, looking exactly the same. They should look like the cheerleaders or the honey bears, and they should be facing the same direction. So it will either look like this with my X in the middle, or it will look like this. They will never, ever point to each other or away from each other. That would be wrong. Okay? Or statements, never together. Okay? Never together. Now, this was a problem that I saw with the or statements. Does anybody remember the symbol for or?
U.
Yeah, it's a U with what?
No
tail on it. Don't put that little stick on the side of it, okay? It's just a U, okay? So on the test and on your worksheet, these were some of the problems that I saw. Some kids would make one set out of this guy and then go union, and they would make another set out of this guy. How many sets should I have? Yeah, one set. That's it, guys. You shouldn't have any more than one set. So really, this should all be in one set. All right, where normally we write any x such that, and then you would have a statement over here, x is less than -2, or x is greater than 8. You see what I'm saying? Don't put it in two different sets. If you did that, I scribbled it out on your paper. I didn't take points away, but I will on this test. Okay, I'm going to expect it to be done perfect. All right, so this is what we're looking at, this right here. Can I tell what it is by looking at it? No, you got to isolate the absolute value first, and then you can. But you have to isolate the absolute value. Okay, so sometimes kids just look at it and they go, oh, that's an or statement. Like, no, it's not. Because when you divide by that -2, what's going to happen to that sign? Yeah, it's going to flip it and make it an and statement. Okay, so you're going to have to isolate the absolute value, then you can decide what kind of statement it is. All right, so here's something else I want us to know. If it is an or statement, okay? If it is an or statement, you are going to do two things. How many things are you going to do? Two. Two things. The first one, flip the sign. The second one, change the sign. Okay? Two things, guys. Flip the sign and change the sign. How many things are you going to do?
Two.
What are they?
Flip the sign, change the sign.
Okay, so why do you think I'm making such a big deal out of it?
Because God's wrong.
Yeah, y'all listen, this is, I mean, more kids mess up on this, and it's really easy, okay? It's not hard, so, I mean, I wanna make sure it's just kinda imprinted on your brain. So, here we go, let's work. Number 4, this is example 4. I'm still on 1.7. This will be labeled 1.7b, solving absolute value inequalities, on your, YouTube. Yes?
I was gonna say, I don't think your phone recorded no more.
What?
Yeah,
It says something about update something.
Oh, I guess it's not anything.
Dang it.
Update
Well,
Apple Watch.
I don't know how to update it, y'all. I've been trying to update my watch and it just keeps saying it's searching for an update. Now it's messing up my life. It's not doing it?
It might still be recording, but it does say that.
It's not recording.
Take your time.
Oh, yes it is. It is recording. Okay.
Oh, my
So, dismiss that, please. Thank you. All right. So, sorry about that. Maybe sometime, maybe after this is over, y'all can show me how to do that because, see my watch, look. I'm going, what in the world is wrong with it? And so then that keeps coming up, so I tried to do it, but evidently I didn't know how to do it. So, maybe y'all can help me. All right, so good. We're still on a good track. So example 4. Okay, example 4. Absolute value 4x plus 5 greater than 13. Okay. All right. First thing you're supposed to do. No.
Wait, is isolate.
Isolate the absolute value. Is it already isolated?
Yeah.
Is there anything around it on the outside that you can get rid of?
No.
No. So he's already out. He's already isolated. So the next thing I want to do is I want to decide what is he? Is he an and statement or an or statement?
Or.
How do you know that?
Because it's
Yeah, it's greater than. Pardon me. It's greater than. So greater than is an or statement. Okay? So this is what we're fixing to do, guys. You see it? It's an or statement. How many things are we going to do? Two things. What are they?
flip the sign, change it.
Flip the sign and change the sign. Okay, so watch what I'm going to do. All right? Here we go. I'm going to take this and I'm just going to write it down with no absolute value. I'm going to say that again. All I'm going to do is take this problem and write it down without the absolute value. So it's going to say 4x plus 5 is greater than 13. Or, you could use the union symbol. That's normally what I would use. I just used both for y'all. Okay? Or, now what am I going to do? What's my next statement going to say?
You're going to flip. I don't know.
Yes, what's it going to say? 4x plus 5
It's
less than negative 13. Flip the sign and change the sign. Flip the sign and change the sign. That's all I did. I took this sign and I flipped it. I took this one and I changed it. So everybody got it? How many things are you going to do? Two things. All right? Flip the sign and change the sign. Now we're just going to solve each one of these. All right? So over here, I'm going to solve this guy. Tell me what to do first.
Check 5.
Okay, so I'm going to subtract 5 from both sides. So I got 4x is greater than, what's 13 minus 5?
8.
Yes. Okay. And then what am I going to do? Divide by 4. Do I need to flip the sign? No, only when you multiply or divide by negative. So then I have x is greater than, what is 8 divided by 4? 2. union. Now I'm going to go work this guy. Okay? So I'm going to do the same thing. I'm going to subtract 5 from both sides. So then I get 4x is less than. What's negative 13 and negative 5? Like signs, you add and take the sign of both. Now what do I do? Divide by 4. Do I flip it? No, don't go. Oh, he's negative. I'm a 4. No, you have to multiply or divide by negative. Not into one, but by one. So these are gone. X is less than what? Negative. Very good. Y'all listen to me. Next week, when the new 6 weeks starts, I'm going to start taking points away from you if you turn that into a decimal or a mixed number. Don't do it. All you want to do is make sure it's a fraction in reduced form. What divides into 18 and 4 evenly? 2. So 2 goes into 18 9 times. 2 goes into 4 2 times. So negative 9/2 is a beautiful answer. Okay? Now, we're going to write them 3 ways. Okay? We're going to write them 3 ways. The first way we're going to write them is in proper set notation. Okay? Proper set notation. So A is going to be proper set. Even if they just say set, we write in proper set. Okay? B is going to be a number line. What else could they call it? They might say write it as a graphical representation. Okay? Y'all listen to me. You only have 1 variable. So that's why it's on a number line. If you have 2 variables, that's on a coordinate plane. If you have 3 variables, that's on a 3-dimensional plane. Okay? But this is just 1 variable. It's only a number line. And then the last way is interval notation. Okay? Interval notation. All right. So here we go. Now I'm going to do exactly what I would do if this were my problem. Okay? I would just take this and start writing this as 1 set, right? How many sets of braces do I want? 1 set of braces. But watch what's going to happen, okay? So I'm going to go, oh, I'm just going to write this. Any x such that x is greater than 2 or x is less than negative 9/2. Is that backwards? Do you understand how that's kind of backwards?
Yeah.
Normally you would do the left part first and then this is on the left on a graph and this is on the right. So I don't really like the way that's written. So I'm going to rewrite it. And I'm going to change their places. Okay? So I'm going to say any x such that x is what? Less than negative 9/2. I want my less than to go first. Okay? Or x is greater than 2. That sounds so much better. Okay? All right. The next thing I want to do is I want to put it on a number line. Okay? Now here are my rules. Remember what the rules were when we did our first interval notation and I said, I like for you to have a positive and a negative and a 0 on that, right? Well now, if you have a fraction, I want to know what 2 integers it goes between. Because I want to know, do you have some concept of a fraction? All right, so here's what my brain's going to do. My brain's going to take this number and make him into a mixed number. Do y'all remember how to do that? How many times does 2 go into 9? 4. So it's negative 4. It goes in there 4 times with how many left over? 1. So it's negative 4 1/2. Okay, so here's my 0. Here's my 2. Where is negative 4 1/2? Between what 2 integers?
5 and 4.
Do what?
Negative 5 and negative 4.
Yeah, negative 4 and negative 5. So negative 1, negative 2, negative 3. Here's negative 4, and here's negative 5. So 9/2, negative 9/2 must be right there. Okay? So I'm going to circle negative 9/2. Do I fill it in? Why?
It's not equal to.
Yeah, it's not or equal to. It doesn't have a line under it. It's not included in my solution. Okay? If you read from the variable, y'all always read from the variable. X is less than negative 9/2 and less than goes to the left. Do I have to put an error on that?
Yes.
If you don't put an error on it, is it right?
No.
No. Okay, so that interval notation worksheet that y'all did, some of you didn't put arrows on that. I gave you credit for it because I didn't really grade that paper. I just made it a completion grade. Okay? I was kind of drowning in papers, and so I just said, well, completion grade. All right, so if you didn't make 100 on it, it was only because you didn't finish all the problems. If you did make 100, does that mean you knew how to do everything on there?
No.
No, it just means you you had something in the blanks. Okay? So, this one right here, I'm going to circle 2. Am I going to fill it in?
No.
No. Reading from the variable, x is greater than 2. Greater than goes to the right. So there's my number line. The last thing you're going to do is interval notation. Now, the reason I made you write it on the number line is because interval notation is really easy to do from a number line, isn't it? You just start from the left and you start reading where the answer is. Well, the answer is this little arrow. Where's that pointing to? Negative infinity, which is never included, right?
Nope.
All the way to negative 9/2. Okay? Negative 9/2. Is that included? No. An open circle, no line. You see how, and a parentheses. All those mean the same thing. Or, this is where you have to use the union symbol. I use it both places, and then I don't have to remember where I have to use it because it's the only thing I use. Okay? And then, where does it start again? 2, inclusive or exclusive? Exclusive, all the way to positive infinity. All right, so everybody okay?
Yeah.
Now, this is stuff you already know. Do you agree? Okay, so really the only thing that's new right now is, am I doing an and statement or an or statement? Everything else on this paper you should be familiar with. Okay, even if it's the absolute value part, we've talked about that before. Okay, so let's do the next problem. We're going to work example 5. Okay, example 5 looks like this. 3 times the absolute value of 2x plus 1, and then minus 7 less than or equal to 11. Okay, can I say this is an and statement?
Yes.
Why? Why can I not say it?
Plus,
You can't say it because you have it isolated.
That's exactly right. Y'all listen to me. That's a very, very, very bad habit to get into. Okay? Because here's what happens. If there were a negative number outside here and you had to divide by that negative number, what's going to happen to that sign? They're going to flip it. Okay? So don't do that. Always isolate the absolute value first and then decide what it is. All right, so if I'm isolating my absolute value, what do you get rid of first? The minus 7. How do you get rid of a minus 7? Okay, so I'm going to add 7 to both sides. So now I have 2 times the absolute value, 2x plus 1, less than or equal to, what's 11 and 7? Oh, thank you so much. 3 times the absolute value of 2x plus 1, less than or equal to, what'd y'all say, 18? Okay, now what do I do? Divide by 3. Now 3's cancel out, and I have the absolute value, 2x plus 1, less than or equal to what? 6. Okay, now can I say what it is?
yes.
Is it an and statement or an or statement? An and. He's a less than, okay? So he is an and statement. Now, and statements are always written together, okay? So y'all listen to me. I'm going to tell you something. I'm going to be really honest with you. I can do it just like I did right here. This is kind of like case 1 and case 2. Do you agree? Except that instead of just changing the sign, you have to flip the sign and change the sign. I could do this one the exact same way. I could write this down and then go over here and write it and flip the sign and change the sign, solve each one of them, and then I would have to go back and put them together because it is an and statement. Or we can just write it as a compound statement and it will already be together. That's the way I like to do it, okay? So that's the way I like to teach it. I told you you could do it the other way if you want to. You have to be very careful because sometimes, because it's apart, then you forget to put it back together and that'll mess you up. All right, so watch what I'm fixing to do, okay? All I'm going to do is write this statement down and take away the absolute values. Everybody got it? Now, when you write it together, what did we say about the signs, these little inequality
You
signs?
change it and you.
No, what did we say about the inequality signs when it's written together? They have to look what? The same. So I'm going to take this same sign and I'm going to put it over here. And then I'm going to take this number and change its sign. Okay? I'm going to show you again what I'm going to do. Will this sign ever look different than this? No. People, if it's an and statement, that's why it's an and statement, because it's a less than sign. So then you're going to write the less than sign over here. If it's or equal to, you'll write or equal to. And then you'll take the opposite of that number and put it over here. Now, watch what I just did. Is this the problem without the absolute value?
Yes.
So this is this thing right here, right?
Yes.
Okay? Now look at it. Did I flip the sign and change the sign?
Yes.
Y'all, if you read it backwards, it goes 2x plus 1 is greater than or equal to negative 6. 2x plus 1 is less than or equal to a positive 6. And 2x plus 1 is greater than or equal to a negative 6. Okay? So I am doing it, but I'm just doing it all at once. It makes it really easy. Okay, so now there are how many sides?
3.
3 sides. Very good. So every time I do something, I have to do it how many times?
3.
3. Awesome. So what's the first thing? I'm solving for this x right here. What's the first thing I have to get rid of? That plus 1. How do you get rid of it? And how many times do you subtract 1? 3 times. From the middle, the right, and the left. In the middle, it cancels out, and you're left with a 2x. Okay? I went ahead and wrote my signs down. On the right, what's 6 minus 1? On the left, what's negative 6 minus 1? Okay? Now what am I going to do?
Now you're going to divide by 2.
3 times, right? So, in the middle, x less than or equal to, what is this? It's 5 over 2, 5 halves. Greater than or equal to, what's this? Negative 7 halves. That's my answer, people. You want to put it in proper set notation? Open up a brace, say any x such that, and close that brace. Okay? The second thing we're going to do is we're going to put it on a number line. Now, think about this. This is an and statement. Normally, what do and statements look like when you graph them? Yes, they're the ones that connect. So they're the ones that go like this. Okay? Like one will go one way and one will go the other. Can I put an arrow on them? No, because they stop. Okay? So they're the ones that are like in between. What do or statements look like? They look like this. Okay? Now, did we address what happens when they don't do what you think they should do? Remember those? We call them weirdos, right? And we talked about what happened to them. All right, just making sure you still got that. All right, so this guy right here, negative 7 halves. That's negative 3 1/2. Do y'all agree? And 5 halves is positive 2 1/2. All right, so 0. Where is 2 1/2 located between?
Between
2 and 3. So here's 1, 2, and here's 3. 2 1/2 is right here. I'm going to call it 5 halves because that's what they called it. Okay? I'm going to circle it. Do I fill it in?
Yes.
Why?
because it has or equal to.
It has that line under it, that or equal to. That means he's part of my solution. Okay? If you're reading from the variable, cover the other part of the problem up and read from that variable. X is less than 5 halves. Which way does less than go?
Left.
To the left. And we're not going to put an arrow because an arrow says it keeps on going and it doesn't. Okay? Negative 3 1/2 is between what two integers?
That's the negative 3.
Negative 3 and negative 4. So this is negative 7/2. I'm going to circle it. Do I fill it in?
Yes.
Yes. Okay, now watch this. Everybody look up here. I'm going to cover up this part of my inequality. And y'all, I'm reading from the variable. I'm reading backwards. X is what? Greater than negative 7/2, and greater than goes to the right. So he looks like this. I like the way that looks because normally that's what they look like. Okay, so I'm thinking, wow, I think I'm on the right track. The next thing I'm going to do is put it in interval notation. So I'm going to read my graph. I start from the left because, why do I start from the left?
Because you need to get your smaller.
And what goes on the left in interval notation? The smallest number. If negative infinity is part of your solution, where will he always be? On the left. Yeah, the very first thing. All right, so here we go. I start reading it. Here's where I come to my answer. So where does it start? Negative 7/2. Included or excluded? Included. Solid dot. Line under it. Bracket. They all mean the same thing. Okay? Comma. And he goes all the way until you get to 5/2. Included or excluded? Included. And that's my answer. Okay? Anybody got a question? No questions? Okay, so I'm going to give you about 15 minutes, and I want you to work 3 problems on your worksheet, okay? These are the ones that I want you to do. I want you to do number 2, number 6, and number 9. 2, 6, and 9. I'm going to give you about 15 minutes, okay? So, look, I have other stuff to teach you, so I'm going to keep the video going because I don't know how to connect 2 videos, okay? So, obviously, if I can't update my watch, I don't know how to do that. They can fast forward through it. Now look, if this was me and I was working this stuff, would I be checking my answer with someone else?
Yes,
I
ma'am.
would be, okay? I would be.
So,
What time are y'all gonna be through? What, at the 35, is that what it is?
right now.
Is that about 15 minutes at the 30, from when y'all started?
I think so.
Okay. What?
No.
Is that all right?
No, I mean, I don't care.
Okay. Well, I mean, I don't know, I can't see the clock, and my watch obviously doesn't work.
Yes, ma'am.
Is your time on set?
What time was talking?
About 35? Okay. I'm gonna grade this one more paper. I'm not taking it up or anything, guys. I'm just, okay. So, let's stop. Some of you got finished, some of you almost got finished. That worksheet is due the next class, okay? So if you did the first 10 problems like I asked you to do, then you only had 10 and I gave you time to work some, so maybe you have 7 or 8 left, okay? So that's due the next class. I'm going to give you another worksheet next class, so it won't be due until you take your test. But this one I'll hand back to you. All right? Okay, so put that up and let's take some more notes, okay? So now we are moving right along and we're gonna start chapter 2. We're gonna do 2.1, which is represent relations and functions. Okay, represent relations and functions. So we're going to talk, at first the kids said, no, we've never done this before. And then when I started and got into the lesson, they were like, wait a minute, I've heard that before. Yes, we have done this. And I was like, I know you have. You just didn't remember. So we're going to do some definitions first, all right? The first thing I want to define is what is a relation. Okay, what is a relation? A relation is simply a mapping or a pairing of numbers. Okay, so when I pair two numbers together, then that's called a relation. The two numbers might have a relationship to each other. For instance, if the x value maybe were r, the radius of a circle, and maybe the y value were its circumference, then I would be pairing the radius and the circumference together, and they do have a relationship with each other. But they don't necessarily have to, okay? It might just be any x and any y. So, let's see how well you can read my mind. Domain. What variable am I talking about? Very good. There's another word that we call it, and it's called the input. Very good. The input. There's something else that we call it, and it starts with in, but it's not input. What is it? What variable is that? Into what? Independent. This is the independent variable. When you learned how to graph, you made a T-chart, and your teacher said pick whatever x's that you want to, and then you plugged them in, and you found the y's. The X's were independent. You picked whatever you wanted to. The Y was dependent upon what X you picked. All right? Range. All right? I want you to tell me with respect to what these things, okay? Not the X, but the, not the input, but the, and not the independent variable, but the, very good. All right? So these are things that you already should know. One of the easy ways to remember is D comes before R in the alphabet, and X comes before Y in the alphabet. So domains are with the X's and the ranges are with the Y's. Okay, so I'm going to tell you 4 ways. I'm going to leave a little bit of space right here because I'm going to come back and write something there. But I'm going to show you 4 ways that I could represent a relation. Okay? Not the only ways, but these are 4 ways. So I could represent a relation just by telling you a group of ordered pairs. All right? Just by telling you a group of ordered pairs. For instance, I could tell you that this relation contains the pairs -2, 2, -2, -2, and 0, 1. All 3 of those coordinates or ordered pairs are in this relation. Another way I could represent them is with a table. I'm going to call it a table, but I will say this. Generally, when you're talking about a table, it goes horizontally, all right? But I'm going to actually make mine vertical, and it's really what you would call a T-chart, right? And the T-chart lists these points. So when X is -2, Y is +2. When X is -2, Y is -2. When X is 0, Y is 1. I could also represent this on a graph. Okay, this time I have an X and a Y value, so instead of it being just a number line, it's going to be a coordinate plane. Luckily, I didn't pick any number like 42, so we don't have to make a whole bunch of tick marks, just a few. All right, so the first point I'm going to plot is this point, -2, 2. So I'm going to go left 2 and up 2, and I'm going to make a big fat dot for an old blind woman. All right, the next point I'm going to plot is -2, -2. So I'm going to go left 2 and down 2. Make a big fat dot. Then I'm going to graph 0, 1. So where do I go for 0, 1? He's something that's missed a lot.
You go straight up.
Yeah, you just go up. You don't go left or right any, okay? You just go up 1. It's 1 on the y-axis. It's 0 on the x-axis, okay? So that's this point right here. Now, the last way we're going to talk about it is what is called a mapping. Now, listen, if I had to pick one of them that kids have a more difficult time with, this is the one that I would pick, okay? You've seen a mapping before. Maybe you didn't remember it was called a mapping, but this is kind of what they look like. We've got 2 circles. This is my input, and this is my output. My input contains the numbers -2 and 0, and my output contains the numbers 2, -2, and 1. They don't have to be in any certain order, okay? But here's what I do know. -2 is mapped to 2. -2 is mapped to -2. And 0 is mapped to 1. That's a mapping. Okay? Yeah, this is the one, we're not going to have time today, but we are going to talk a lot more about this one because this is the one that will mess kids up. I can get you with this one, and it's not going to be hard for me to do that. Okay, so the next thing I want to talk about is domain and range. we're gonna list the domain and the range of this relation that I've given you, okay? Now, here's what I want you to know, and I'm not gonna say it anymore, okay? That if I ask for the domain and the range, I want it in proper set notation. Now, do you think I'm gonna ask for it on that worksheet? I am. And if you don't put it in proper set notation, then it's gonna cost you. I'm not gonna tell you to, because I've already told you. If I'm asking for domain and range, I want it in proper set notation, okay? Not the worksheet that you have, but the one I'm gonna give you next class, okay? So, domain, first of all, starts with a brace. Who is the domain? The x. So it's gonna be any x such that x is equal to, what is my domain? Yeah, -2 and 0. So I'm going to put -2, comma 0. Are you with me? Okay. The next thing I'm going to do is the range. All right. Who is the range? The y, such that y is equal to. Now guys, listen to me. You could put it in any order that you wanted to, but I will say this. If there's a bunch of numbers, it's going to be best to put it in some type of order, like from least to greatest or something like that, okay? So we're going to put these from least to greatest. Come on, people, help me out. All right, so what's the smallest one? -2. Now, look up here. There were 2 -2s. Am I supposed to write both of them down?
No.
No, because that's redundant, right? That means you're doing it more than one time. That's silly. If I say -2 is a member of that set, then he's a member of that set, okay? So -2, what's next? 1, and what's next? 2. So there's my range. All right, is everybody okay? Okay, so the next thing I want to talk about is a function. Do y'all remember talking about functions in Algebra 1? Okay, here's the definition of a function. A function is a relation where every x has only one y. Okay? Every x has only one y. Another way to say it, I really like this way. Every x has exactly. What does the word exactly mean?
True.
Can it have more than? Can it have less than? No. So exactly means no more, no less. Okay? Exactly one y. Okay, so what I want to do is I want to take this definition and I want to go up here and I want to talk about how do I tell if these representations are functions or not. Okay? If I give you a list of ordered pairs and I say, is this a function? How would you tell someone? What's the easiest way to tell someone to tell if this is a function?
See if the x's repeat.
That's exactly right. Good job. So, Charlie says the x's cannot repeat. If the x's repeat, it is not a function. Okay? So, is this guy a function? No. Justify your answer. Negative, very good. -2 repeats. Do you see how I was very specific? I didn't just say the x's repeat. Obviously, you think they do because you said no, all right? But why? Because -2 has 2 y's, all right? He repeats. What about a table? A table is very much like an ordered pair. Do you agree?
Yes.
So if I want to know if he is a function, I'm still saying that the x's cannot repeat. If your x's repeat, it is not a function. Okay? What about a graph?
It should be the same
It
thing.
should be.
No straight lines, no verticals.
Okay, so on a graph, it must pass, what's that called? Yes, the vertical line test. Okay, the vertical line test. So here's what the vertical line test says. It says if you take a vertical line, all right, so here's my vertical line. If you run it across your graph, it cannot touch your graph in more than one place at a time, okay? It cannot touch your graph in more than one place at a time. So I start running it across my graph. Y'all, as soon as I hit that first point, what did I just hit? Yeah, I hit 2. So as soon as I bumped this point right here, I bumped another one right there. Y'all, look what you just said. This x value right here has 2 y values, okay? That's why he's not a function. Because this x, if you hit that graph in more than one place at a time, it's not a function. So right here, womp, 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 nope, not a function. Okay? All right. On a mapping, this will be the one that's the hardest one. There is no kind of secret test or anything like that you can do. All you have to do is you have to ask yourself, did you follow the rules? Does every x only have one y? Does this x have one y? No, he's not a function, okay? So did you follow the rules? That's the easiest way to tell if a mapping is a function, okay? So let's do one of them. We'll just do one mapping and then we'll stop. Okay, we got about, no, what, we got 10 minutes. We may do more than one. Okay,
I got 7 minutes.
we got 7 minutes?
The clock is slow.
Oh, okay. So this is example 2. And all I want to know is this a function? Okay, that's all I want to know. All I'm going to do right now before the bell rings is I'm going to do mappings. Okay, I'm just going to do mappings, and then when we come back next class, then I'll start with the graphs. All right, so here we go. Here are my mappings. My 2 little circles. Naturally, the first one is the input. The second one is the output. The input contains the points -3, -1, 2, and 4. The output contains 2, 3, and 4. And it looks like this. So what I told you to do was to go down each one of those inputs, each one of those x's, and say, did you follow the rules? Does every x have one y? Does this guy have one y? Does this guy have one y? Does this guy have one y?
Yes.
Does this guy have one y?
Yes.
Is this a function?
Yes.
Very good. Okay, here's my next one. Are you ready? My input is -3, -1, 2, and 4. My output is 2, 3, and 4. And it's mapped like this. Don't say the answer out loud. Nobody likes that. What do you say?
No.
Did he follow the rules? Does this guy have one Y? Does this guy have one Y? Does this guy have one Y?
Yes.
Does this guy have one Y?
No.
Then it is not a function. Okay? this a function?
Yes.
Yes, it is. Seems weird, right? But this guy has a y, this guy has a y, this guy has a y. It's a function. He follows all the rules. Last one. -2, 1, and 4. -4, -1, 2, and 3. Yes or no?
No.
Reason.
Because one input has two outputs.
Very good. 1 is mapped to -1 and 2. All right? Good job. Okay, so your worksheet's due next class. You need to have that done.